So let us continue with our journey of indices. All right. So just to revision quickly, we remember that the 8 is the base, the little number here being the 2 is the exponent or index. You can have a 0 index, and anything to the power of 0 is 1. Unless you have 0, then it's indeterminate. You can have a positive index, which is all the stuff that you know already. And that just says how many of these numbers are being multiplied together. And then you have a negative index, which is kind of like the positive one by saying how many are multiplied, but it's just saying that it's in the wrong place in the fraction. So therefore, if it has a negative index and it's currently sitting in your numerator, it should be in the denominator. And if it's in the denominator with a negative index, it should be in the numerator. So for example, you have 2/3 to the power of -1. That means you need to tip or flip the fraction. So 2/3 becomes 3/2. Now, you may notice that the exponent seems like it disappears. It doesn't. It goes from -1 to +1. But remember, a +1 exponent we don't write. So just as if you have a -2 exponent here, so 3 to the -2 means the 3 is currently in my numerator. It should be in my denominator. Therefore, it's 1/3 squared, and 1/3 squared is 1/9. Then we had something that looked like this. Now, some of us did this last week and some of us didn't. So we are going to just go over it quickly again. So now we're going to apply what happens if you multiply with exponents that have the same base. So first thing you need to do is you multiply the numbers, being the coefficients, in front. So 5 times 4 gives me 20. And then we have an x squared times x cubed. Now, if it's x squared times x cubed, the x squared can be broken up into x squared times x squared. The x cubed can be broken up into, x squared is x times x cubed is x times x times x. So when you multiply them, you end up having 5 x's, being x to the 5. And we see that we can make a rule from this, that if you're multiplying items with the same base, note we've got an x and an x, both are the same, then we can just write down the base and add the indices to combine them. Therefore, the final answer of this would actually be 20x to the 5. Now here it's quite easy to see that you just put an x. Some examples you'll come across, the base is actually a number. And a very common misconception that you'll come across is that people will want to multiply these bases. So they'll say 2 times 2 is 4, and then you add the exponents, and that becomes 4 to the 7. That is a huge problem, because this is actually 2 times 2 times 2, times by that is times 2, times 2, times 2, times 2. But this is all 4s. That's a problem. So because of this, this is a lot bigger than that. So this is a huge problem. This actually is still 2 to the 7. We keep the same base as it is, and we just add the exponents. All right, everyone's on the same page. So then what if we have an example like this? So now we are dividing instead of multiplying. So we have 6 divided by 3 gives me my answer of 2. Then we have x to the 4 over x cubed. Well, x to the 4 is 4x's multiplied, and x cubed is 3x's multiplied. So when you write them as a divide sum, you're going to cancel the 1, cancel the next one, cancel the next one, and you're left with only 1 at the top. And that is why your answer is 2x. But again, we can come up with a rule for this. And the rule says that if we divide with the same bases, you must just write down the base, and then you subtract the top index and the bottom index. So you subtract the bottom from the top. Top minus bottom. So 4 minus 3 gives me 1. Remember, a 1 we don't write, so it's just 2x. And again, it's exactly the same if this isn't an x and a number. It works exactly the same. So we have 2 rules. So currently, if you multiply, you add the exponents. If you divide, we subtract the exponents. And then we have one last rule. And this last rule is when you have an exponent outside of a bracket with exponents. So this is an exponent raised to another exponent. So we need to make sure that we know what is being shown here. And essentially, this is saying that there are 4 2x cubes multiplying together. So it's 2x cubed times 2x cubed times 2x cubed times 2x cubed. So we have 4 2's multiplied and 4 x cubed multiplied. So 2 multiplied by itself 4 times is 16. And then we know from our multiplication rule that we add the exponents, so 3 plus 3 plus 3 plus 3, and that gives me 12. And therefore my answer is 16x to the 12. And we can make a rule for this, that if we have this on the outside, you simply distribute the exponent to the 2 and then to the x cubed. So it's 2 to the power of 4 is 16. But when you have an exponent raised to another exponent, you simply multiply the indices. Just as here, this technically is 2 to the 1. 1 times 4 is 4. That's why it's 2 to the 4. That leaves us with this game that you're going to be working on for the rest of the time. I suggest probably taking a screenshot or something of this. Unless you want to write it out, that's totally up to you. So you need to use these 3 rules and simplify each of these 24 problems to get to a single answer, being it a single x to the power of a number. And once you have all of these answers, you'll be able to link those answers to specific letters. And once you have linked those answers to letters, you're going to look at this bottom row here, and you're going to put the letter answer corresponding with the question number in each of these blocks to answer the question why the number 4 didn't get into the nightclub. Now, yes, I know I sound very old by still calling it a nightclub, but let's just move on from that. All right, so for example, the first one, 13 here. So the answer of question 13, put as a letter, is going to go in this block. And I will start it off for you just to show you what I'm doing. So this is an exponent raised to another exponent, and that means that we multiply. So 9 times 5 is 45. Another exponent raised to an exponent means we multiply. 8 times 3 is 24. And when we divide, we know that we subtract our answers. So therefore, 45 minus 24 gives me 21. So that is my answer of question 13. I now need to link this answer with a letter. And you'll notice that all of these exponents are actually in ascending order, starting from the lowest there and finishing with the largest there. So we look for 21, x to the 21 links to b, and therefore we write b in the block.